Hello, this is the fourth video in our series Learning about Order in Operations in Mathematics. We've learnt about BIMDAS, the acronym that helps us remember the convention for evaluating mathematical expressions. But we did say in earlier videos that we were going to explore what the meaning of the I in the acronym BIMDAS was all about. Now the I simply comes from index, the plural of which is indices. And what we're going to look at now is what is that I all about? Now you may or may not know, but if you have an expression like 2 times 2 times 2, mathematicians have a very elegant way and a simple way of writing that expression. And what they write is simply 2 to the power 3. Now there I've used the word power, and we'll talk in a minute about why you might use power, basically because these things are very powerful. But the power 3 is what we call an index. So that's what an index is. When there's plural, of course, we've said indices. So let's try another one. 4 times 4 would be 4 squared, or 4 to the power 2. And notice I've used a couple of extra terms there, haven't I? 2 cubed, 4 to the power 2. Let's try another one. 3 times 3 times 3 times 3. What we'd say is we'd write 3 to the power 4. So there's our index, it's a 4, and it indicates that we mean 3 times 3 times 3 times 3. Now these things can get very big very quick. 3 3s are 9, 9 3s are 27, 27 3s, I know you know it, 81. 4 squared, 4 times 4, 16. 2 cubed, 2 2s are 4, 4 2s are 8. And you need to be careful because these things can become very big very quick. I'm just going to move that up a little bit just so we can still see BIMDAS, of course. Or maybe, why don't we pop it just here where we've got a little bit of space. 2 to the power 10, just for example, means 2 times 2 times 2, 10 times. Now if you work that out, what you will find is that it becomes 1024. And that's where the term power comes from, doesn't it? There really is some power. 2 to the power 10 is 1024. Of course, if you go 2 to the power 11, you're doubling 1024, which would become 2048. So these numbers can become very large very quickly. So that's what an index is. But then you're probably wondering, how does this relate to order in operations? Well, there's our I for index there. We know that multiplication and division go left to right. We know addition and subtraction go left to right. So for example, let's say we had 10 minus 2 cubed, and we had to evaluate that expression. Now I've said 2 cubed again, or you could say 2 to the power 3. Do we do the 10 minus 2 and then cube it? Or do we do the cubing first before we do the subtraction? Back to our acronym. There's the I for index. There's the S for subtraction. Obviously, we have to do the index first. So we know what 2 cubed is. We know that it's 8. So 10 take away 8 would be equal to 2. If we wrote, however, 10 minus 2 to the power 3, well, there we are. We've got those brackets out again, and they're very powerful, aren't they? We've said that. They're the boss. So the 10 minus 2 would be 8, and then we would have to do the index. Now, 8 times 8 is 64, times 8 again is 512. Now, I don't expect that you can necessarily do that mentally, but you could equally evaluate that on a calculator. So that's introduced us to indices. We'll do a lot more on them later, but I just wanted you to have a look and see what an index was, how it fitted in, and then to give you a couple of examples. And we'll explore its use more widely in later videos. Thank you.